Hi guys, welcome back to Aid's Workshop. I think this is going to be part 6 of the X-axis power feed. There is a bit of machining, a little job I had to do for work, well a few actually, little machining jobs in this. The final sort of bits of the power feed basically are electrical, basically sorting out all the wiring, all the rest of it. I had to do a few changes, as it turned out when I had the power supply up on end. The lid was like 2 millimeters from tightening up when I put the 4 screws in. So I had to do a rethink on that. So I'll show you that. So here's the box in position under the bench where it's going to live. The power supply now, I've flipped it 90 degrees and it's lying flat. So 230 volts in, 224 volt supplies, one for the motor controller and one for the controller board. All the cabling going out via this lead through the 10-pin sockets. I put some protective sleeving on. As you can see, that's running up to the actual feed unit on the end of the mill. Now, at one point, I had, you can see the board. I was trying to pick up off the 2 switches on the board here, trying to pick up the 2 wires, and a subscriber or somebody certainly commented that that won't work. Obviously, not being electronics minded per se, I took that on board and found another way. So what I've done is I've used the enable line, or the negative enable, which got from this switch. So basically when you push the on button on up here, it basically feeds a negative feed out of one of these lines here onto the stepper motor, which is the enable line, negative enable. And I've basically ran that via the loom up to an on-off switch up the top. And again, the directional switch, when you push the button on here and it changes direction, it basically makes or breaks a negative line to the stepper controller again. So I've run that via a switch, which again runs up through the loom to a directional switch on the mill. So I'm basically replicating what this board does in its communication to the stepper controller. I'm replicating that, but I'm replicating it up on the mill. So instead of sort of trying to piggyback the switches, I'm basically piggybacking onto the function that the switches do. So yeah, now it actually works, and it works fine. So yeah, the box is down here. Again, somebody has said that temperatures are going to be a problem because we've got a hot transformer. So I don't know whether you can see, I got a load of holes in the bottom of the box, a load of holes in the top of the box. And I've been monitoring it. I sort of ran it back and forth for an hour or 2, which is about as much as I'm going to do on slow speeds and full speeds and all sorts. And the temperature in there was stayed cool. So yeah, I think we're okay. Here we are. Let's cover back on, and the box is living under the bench, and the power lead running up here to the motor. So just to give you another view, I've got my pot right here where I can adjust the feed, and it's right at the point where I'm going to be using the machine. So it's protected under there, it's not going to get bashed. And yeah, happy days. So, plugged in, switched on. On-off switch here. Directional. Back the other way. Back the other way. So, you can feed in both directions and switch off at any time. While I'm running my pot down here, I can change direction. So that would be about as fast as it goes. I'll do a couple of little experiments just to see what it is millimeters per minute in slow and fast, what my range is. Got my X-axis on the DRO set to 0, not sure if you can quite see it there. Stopwatch on my phone, go. Oh, hang on. Should we try that again? Okay, I pressed off screen instead of start on the stopwatch, and go. Yeah, so I'm just going to check over the space of a minute, switch it off after when I get to a minute on my stopwatch, and then see how many millimeters I've travelled. So we've got to a minute, well, all by the shouting. I switched the power feed off. And let's have a look, see if we can bring you in on my screen. There you are on the top line there. 13.59, so 13 to 14 mil a minute minimum. So I just run it 100% up the other way, and my reading is 408.7. So from 13 mil a minute to 410 mil a minute is my range of feed. So yeah, I mean, it's pretty good. I'm quite happy with that. I mean, it's as fast as I'd want it to go, and it's probably as slow as I'd want it to go, so it's doing what I want. I think I want to make a little improvement down here, and perhaps have a green light or a red light on there that tells me that I'm switched on the wall. I don't want to leave it switched on. So yeah, basically to tell me that the transformer's powered up. So I'm going to put a light on there that runs on the same power supply on the 230 in. I've got some 230 LEDs, and I'm going to put one in there to sort that out. I've just marked out where I want the hole, and a quick gauge of the hole size I need. Let's go there. Oh, we don't want a hammer drill, do we? I've been putting up a couple of blinds in the house, and as you can see, I've still got plasterboard dust on the end of the drill bit. And the last time I used it was on hammer to put some more roll plugs in the wall. So yeah, oops, probably go a bit slower than that. I've gone right down low so I miss everything inside. It just saves me taking it all off again. I need to go right through with this. The hole is 21.9, it measures the light I've got. There we go. So that's a nice round hole in there with a step drill. And the little light fitting is here. And that's going to fit there like that. And I'll wire it into the 230 supply. I have unplugged everything. And everything should be hunky-dory. Well, there we are, as you can see. Green light is on, tells me the power's on the wall, and obviously if I switch it off on the wall, power's off, all dead. So, little job of work. Let me just pull it back out the truck. It's a fitting that goes in a sump of a big diesel engine. I'm talking 8-9 litre, that sort of size. There's a drain pipe with a tap to change the oil, to make it simple to change the oil. But the problem we've got is that where the fitting fits into a sump on a 45-degree angle like this, the floor of the machine, or the fuel tank of the machine, is about this close. By the time we have the hydraulic fitting going sideways with a swivel on it here, it's too close to the floor. There's about 3 or 4 mil of gap, but I want to raise the whole thing back up a little bit so that I've got a bit more clearance underneath to allow for movement of the engine on this machine. Without the sump plug, or the sump tap, shall we say, hitting on the floor of the machine. So yeah, I mean, it's a simple little job, but if you haven't got a lathe, it's nigh on impossible. You know, it's one of those things. So basically I'm going to get a reading on here. Just touch up on there. Touch up on the thread, get a reading. I'm going to skim the thread back. I'm going to go back 5 mil with everything. So yeah, just skimming it back. There is room under the nut for it to screw up another 5 mil without any issues at all. When the nut screws on to tighten it all up. There we are, that's back 5 mil. So happy with that. I think I need to get a little chamfer tool in now. I tell you what I'll do. I'm just going to... No, I think I'll take the whole thing back as one. So I'll probably have to do a bit of jiggery-pokery with my tool here. Will that do it? That tool looks awfully high. Yeah, it is. Need to lock that adjuster off. I'm going to swivel the tool round in the tool post, or in its tool holder. So one of the drawbacks of having a fixed tool post rather than the swivel one. I might make myself up another tool post at some point. It's a job that's got to be done, I suppose. A tool post that will swivel. So I'll just set that tool on the correct angle there. I can put it back in square afterwards. These ball-ended Allen keys aren't much good when you want them tight. Let's just check. Yeah, I got the correct angle there. So let's have a look. I'm just going to give myself a 0. Drops there. So I know that I've got to finish 5mm back from there, so I'm not going to take it in one cut. A little bit deep. I'm just reducing it gradually to my shoulder at 4.5. So I've replicated the shape now, 5mm back. I'm just going to put nice bit of leading in there. Very similar to what we had originally. And that's the job done. Well, here we are. That's the job finished. So simple little turning job for work. Just a piece of galvanized pipe. It needs to be just, basically it's been hacked off with a grinder basically in work. And it just needs to be finished to 38mm long. So I'm just going to clean up one side. I think this is the better side of the two. Since my last little adventure on the lathe, I've tightened up the drive belt. It was skidding quite badly last time I did a bit of turning, and the drive belt was slipping quite badly, so yeah, basically just space that off true. Let me just see if I cleaned up. Yep, pretty well there. Change to a chamfering tool, which is lurking here somewhere. Well, that's close enough. Not the one I usually use, but that's fine. Got a big chunk out of this tip. Okay. And I think my old friend, the Noga deburr, not my old friend, but my new friend, the Noga deburring tool, I think might be the answer here. The knocking noise is the weld inside the pipe, I believe. Yeah, I can feel a little weld there. Okay, so that's one side done. Flick him around the other way. I think what I'll do, I'll just get my turning tool back up. Where are we? I'll just set a 0 on against the chuck face. Ooh. That'll give me, I mean, it's not critical dimension, this. Set a 0 there. And then I've got a 38mm. If I put that hard against the jaw, 38 will be my finished size. That's 40.5. 40. And it's actually a spacer that goes behind a pulley on a shaft of a petrol engine. The pulley's on a key and it's bolted so it can't come off the end of the shaft. There's a bolt through the centre of the shaft, but it actually can slide backwards on the key because there's more shaft than there is pulley. So this little spacer goes against the shoulder on the shaft, and then the pulley tightens back hard onto this little tube or spacer, which sorts it all out so it can't move back and forth on the shaft. And once the pulley's tightened down with a washer on the end, it's like a bell washer, so it pulls it hard against this spacer all the time. Everything's located solidly. And there we go. So we've now got a method, and that was 1 of 10. Let's just do a quick little measure. 37.86, 37.9192. That's absolutely fine. 37.9. So yeah, I think we'll where are we? Oh, it's all upside down on you. Hang on. Let's see if I can come in. Yeah, 37.86, 37.9, that sort of idea. So it's in spec. I mean, it's, if it was 37.7.6 it would be alright, and if it was 38.5 it would be alright. But yeah, simple, quick little job. Job's a good one. So I had a plan A to replace the 2 stops here against the sort of middle part with a couple of little adjustable micro switches that would, you know, come up against something, clunk, break the circuit to stop overextending the travel with the unit. Somebody mentioned, why don't you put one in the middle, you know, so I'll have something in here, a little switch, and so you can adjust the stops, so I can have my final stops locked or what have you, maybe a bit further back than where they are now, and then so internally some adjustable stops that when they're right to the outside will be the extremes of the table, so we don't go beyond the DRO, that sort of thing. But I could, if I wanted to, bring them in or preset them to give me a specific range, and I quite like that idea. So the thinking is I'm going to remove this block in the middle, which is the current stop where, you know, when you were hand winding these would come up against, and put a little switch in the center here. And I think, let me just bring you over the other side. So my thinking is a block of aluminium, something like this, sink this little micro switch into it. The wire's going to be fixed in this instance, so it'll probably drop down through a hole in the table with enough slack to allow travel in Y. Perhaps a rod will pass through the aluminium with a couple of rings on it, you know, that can be adjusted up and down just to get it set. Maybe springs on the outside of the rings in the pocket, so that if the rod is pushed from this end, the ring will come along, push the switch, and always self-centralized because of the spring either side. And the same, if the rod is pushed this end, the ring will come along and push the switch. So yep, this is very much going to be a make it up as you go along job, as per normal. So yeah, I think I'm going to cut this piece of aluminium off here, and we'll see what we can come up with. Well, this is fun. First time using a new Powerfeed. Yeah, great. Probably go faster than that. Definitely could go faster. It's cutting 2mm slot, 8mm cutter. I just happen to have an 8mm collet, that's why I went with an 8mm. And it's long enough to go all the way through. To get to the end of a cut, switch power off, reverse direction, let's come down, low 2mm, and back the other way. And there's my brush. Bit WD-40 down in there. And you probably spotted the can of Fosters. There's nothing in it. It was for comic effect. I'm not actually drinking it. Not while I'm machining anyway. Let's have a feel. Yeah, I could go faster than that. About right. So I'm just chopping this piece off, basically. Then I'm going to block it up. And we'll go from there. So yeah, final cut. What is it? It's 3/4 M8, 3/4 deep. You see the block starting to jump around now. And it should just fall off the back, or it's going to snap the cover. There we go. I did actually come into this space a little bit because that was a sawn face before, and at least it gives my piece of block a machined edge should I need to use it again. So yeah, always good little tip. If you've got something, you know, it's worth leaving a machined edge on it so you've got a reference space for next time that piece of aluminium comes into use. Well, I think that's about it for this one, guys. Nice to get back into a bit of machining for a change and to be able to actually use the X-axis Powerfeed. It's been a few weeks of planning and what have you to get all the bits and pieces together, but yeah, now that it's working, yeah, it's going to be a great addition to the mill. Anyway, as usual, guys, thanks for watching, thanks for subscribing, and we'll see you all soon. Cheers now.